For question number 16, it's about Richard taking a multiple choice test. We know there are 10 questions on the test. So N is 10. There's 5 answers. So think of a multiple choice with A through E. So the chance of you guessing correctly, if you're just guessing, would be 1/5 or 0.2. So since we know N, we are going to use binomial dist on Desmos. A, what's the probability he's going to get all answers correct? That means he's going to get all 10 correct. So on Desmos, remember, if you just want one answer, that's fine. Just make these both 10. So 10 to 10, chances of him guessing and getting everything right is practically 0. So I'm going to go ahead and write that answer down. 1.02 times 10 to the negative 7th. Okay, question B is what's the probability he's going to get all the answers wrong? So basically that's like saying he's going to get 0 answers correct. And that is 0.11. So that's what I've gone ahead and written down, is that our x is 10, and here our x is 0, and we got 0.11. Question C, what's the probability he's going to get at least one question right? At least one question right means he's going to get 1 or more correct. So 1 to 10 questions correct, okay? And that's going to be 0.89. I know that's the opposite of this answer, but I can just show you. So instead of 0 to 0, if I change this from 1 to 10, it's 0.89. Okay? And D, what's the probability Richard will get at least half correct? Well, half is 5. At least 5 would be 5 or more. So on Desmos, just make it say 5 to 10, and that's 0.03. So those are your answers for number 16. All right, number 20 is an interesting question. We're talking about 20 men wearing a necktie. There's a 10% chance it's too tight. So this again is going to be binomial. If you know N, you know it's definitely going to be binomial, and that's when we use Desmos. Okay, and you can go ahead and do these with Desmos. At least 1 would be 1 to 20. More than 2 would be 3 to 20. No tie is too tight would be just 0. Okay, and you could go ahead and type those into Desmos, and then we'll talk about D. And hopefully you got 0.88, 0.32, 0.12. Question D wants to know at least 18 ties are not too tight. So does this make sense? The probability they're not too tight is 90%, and that's how I personally think is easier, is change it to 90%, and then go ahead and at least 18 means 18 to 20. So you can see what that looks like on Desmos. I changed it to 90%, made it 18 to 20, and our answer is 0.68. Question number 9, we're just going to do part A. You can read what this is about, but we have 10 households, so that's our N, and our probability that they are buying photo equipment is 80%. And we're asked to make a histogram. I'd actually rather you guys make a bar graph, but when you do this on your test, on your x-axis, you need to go from 0 to 10, and you can start 0 right at the line. Okay. And this is the number of people who buy photography. That's what this is about. So you can kind of label whatever it is you're talking about. Over here is going to be the probability. Well, I'm going to type it into Desmos first. Okay, so I did my 10 and my 0.8, and then see my highest dot is at about 0.3. So that kind of lets me know that's what I want to label on my y-axis. I want to get up to 0.3. So 0.1, 0.2, 0.3, and that was at 8.3. So you're just going to click on Desmos. You're going to notice on Desmos the first couple dots are really, really low. So you can just kind of like, I don't know, draw some flat little lines here. These are really, really short. And then once I get up to 5, it's getting a little bit higher. And again, just kind of look on Desmos to find the value of these points. And then go ahead and draw your bar graph. So don't forget to label the x-axis and the y-axis and draw on your bar graph. And then our mean would be n times p, which is 10 times 0.8, which is 8. And note that's the highest bar. And our standard deviation is n times p times 1 minus p, which is radical 10 times 0.8 times 0.2, because 0.8 and 0.2 are opposites, and that's 1.2. So there is your answer for page 219. Here are the answers to the back page. A lot of these are just practicing your mean and standard deviation. So mean is just n times p, and standard deviation is radical np 1 minus p. So you can go ahead and check all your answers for those 3 questions. You can pause and look at your answers. And then finally, the last one on this page is finally a geometric problem, because they're asking about the first success. Okay, and we're talking about flipping a coin. I kind of don't like this problem because the chance of you getting heads is 50% and tails is 50%, so they're not different numbers. So you can go ahead and look at the work for that. Hopefully it makes sense. The probability that the first head will be on the second trial must imply that you had a tail first and then a head on the second trial. That's obviously 0.25. This question, that the first head will occur on the 4th trial, well, that means you got 3 tails in a row and then heads. And we type that into a calculator. Now this one's a little bit harder. I'm going to do it with you. After the 4th trial, that's what we're trying to find. So it happened on the 5th, 6th, 7th, 8th, blah, 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 blah. If you have this problem, you need to apply the complement rule, okay? So this is what we want, is more than 4. So let's figure out what we don't want, less than or equal to 4. If you have less than or equal, that's when you want to do CDF, second VARS, and then geomet CDF. Okay, our probability of success is 50%, and we're plugging in the 4 for X, because this is going to do less than or equal to. Okay, and we get 0.9375. So that's our complement answer. So if we do 1 minus 0.9375, we get 0.0625, and that is the actual answer that we want to keep. Okay, and finally, the last thing we're going to go over is this. Not because Tom Brady and we had the Super Bowl coming up, and it's kind of unexpected. He would make it again. Okay, I looked this up. It's true. His career completion percentage is 64%. And so we're going to do binomial on some of these and geometric on some of these. So suppose we know in the Super Bowl he is going to attempt 40. What's the probability he completes at least half? So this is saying, hey, we know he's going to pass 40, and we want to know that he passes 20 or more. So if we know our n, we know it's binomial, and we type it into Desmos. Okay, and here's what the distribution looks like, 40, 0.64, and 20 to 40. All right, well, we're very confident that's going to happen, 0.976. What's the probability there's at least 10 incomplete passes? At least 10 incomplete passes. Well, there's still 40 total. The probability of incomplete would be the opposite of 64%. Does that make sense? So we want to change that to 36, and at least 10 is greater than or equal to 10. So I'm going to change that on Desmos to a 0.36, and then I'm going to go from 10 to 40. And I'll show you what that looks like. So I changed it to 0.36, made it 10 to 40, and we get 0.95. 0.950. Okay. Now I'm going to stop using Desmos because, look, this is about a first pass completion. So say it's the start of the game. What's the probability his first pass completion is the 3rd attempt? Well, that means we had not complete twice, and then we had a completion, right? So the probability of not complete is 0.36 squared, times 0.64. Okay, so 0.36 squared times 0.64 is 0.082. We could have done the same thing with geometric PDF. So if we do second distribution and PDF, so what you want to do is your completion value, 0.64, and the 3rd, that he gets exactly the 3rd try. And we're going to get it's exactly the same. So whatever method you like is fine. Okay, here's the difficult one. What's the probability it's going to take at least 4 attempts until he has his first completion? So at least 4 means 4 or more. That's what our goal is to figure out. Well, our calculator does not do that. It will do the complement, So if we want 4 or more, we want 4, 5, 6, 7, that means our complement would be less than or equal to 3, correct? 3 or less. So for complement, or to add up numbers like 3, 2, and 1, we're going to do geomet, CDF, and we're going to do his completion rate, and we're going to do this number. All right, so second distribution, CDF, 0.64 and 3, and we get 0.953, and that's our complement, okay? So for our answer, we're going to do 1 minus 0.953, 0.047.